All right, you've heard about it. We're going to talk about it now. It's called the dark web. All right, so anytime that we talk about the dark web, it's really interesting and important to understand where it sits in the whole scheme of things. First of all, when you think about the internet, you can almost divide it into three different areas. First is what we call the surface web. Now, that's only about 4% of the internet, and that's anything that the Google and the Yahoo spiders can crawl. And basically what they're doing is they're going through and indexing every word and every picture, and that's how we find things so quickly on our search engines, because they can see and index anything that is on the surface web. Well, just underneath the surface web is something that we call the deep web. Now, the deep web is what you in your corporate environment or your government environment are on, right? Not just anybody can come into DOJ and log on to the DOJ intranet. You have to be logged on as an authenticated user. And so, of course, Google, Yahoo, Bing, the search engines, DuckDuckGo, they can't come into our environments, universities, companies, and see what's inside our company and index it. Also, think about any of these websites that are dynamic. So you want to search for flights from Washington, D.C. to the Philippines or your country of choice. You want to go on vacation. Well, the prices for that airline are not on the surface web. They're in a database that has to be queried. And so that's all part of the deep web. Now, for those mathematicians sitting out there that are saying, wait a minute, 96% deep web, 4% surface web, we're done, that's 100%. Well, there's less than 1% is what we call the dark web. Now, the dark web requires a special vehicle. So here I've got my little black submarine, but that special vehicle is most commonly recognized as a specially configured web browser. Now, the dark web was actually created in the mid-90s by the United States Naval Research Laboratory. It was a project by the DARPA, and it was designed so that you could, or we, the United States government, could surf to websites without telling them, hey, I'm the United States government. For instance, if you surf to any website from within the Department of Justice, that's going to come with an IP address that starts with 149.101. Anything that starts with 149.101, chances are you know that that is the U.S. Department of Justice. Well, so what Tor does is it hides your identity. And all Tor is, the onion router is what it stands for, because it's like an onion, peels different layers through the security. Tor is really just a specially configured web browser. Now, it's super easy to get. All you have to do is go to the torproject.org. There, choose which operating system you're using, and it will download, again, that specially configured version of Firefox that allows you to get on the Tor network. Now, normally when we're surfing the internet, my computer here would go directly to the web server that I want to look at. So if I want to go to CNN.com or FoxNews.com or ESPNSports.com, my computer goes directly there. And this web server, they know what my IP address is. Not only that, but they also know what type of operating system I'm using, whether I'm using a phone or a desktop, and a lot more information. Well, when you're using the Tor browser, this specially configured version of the Tor browser, as soon as you start it, the very first thing that happens is it goes to one of 13 directory servers. These are called Tor directory servers. And these directory servers will assign you 3 Tor nodes. Now, these Tor nodes, you can think of them like proxy servers because that's what they're doing. They're proxying information. But it's a little bit more complicated than just being a proxy server. And the reason why is when I'm using that Tor browser and I get on the Tor network, I have an encryption key, as well as all these Tor nodes. They all have encryption keys. So after being issued my 3 Tor nodes, here you can see I've got an entry node, a relay node, and an exit node. What happens is my computer will trade half of my encryption key, or what we call my public encryption key, with the entry node. So the entry node gives me its public encryption key, and I give it my public encryption key. So it's really just half of the encryption key, so we can't do much without it. Then I share my encryption key, half of my encryption key, or my public key, with the relay node and the exit node. Now, anytime that I want to do anything using Tor, whether it's on the surface, deep, or dark web, what happens is my request, in this case, my request to go to evil.com website, my request is placed into an envelope and encrypted with the exit node's encryption key. Then that envelope is placed in another envelope and encrypted with the relay node's key, and then that envelope is placed in another envelope and encrypted with the entry node's key. Now, this request to go to evil.com, triple encrypted, is sent to the entry node. Now, the entry node knows who I am because it's got to know my IP address because it received information from me. But he doesn't know where I want to go on the internet. And the only thing that the entry node can do is decrypt its outer envelope and pass that information to the relay node. Now, the relay node doesn't know who I am. Now, the relay node doesn't know who I am. It only knows who the entry node is. And all it can do is decrypt its envelope and pass that information on to the exit node. So now you see the entry node doesn't know where I want to surf on the internet. The relay node doesn't know where I want to surf on the internet. And the relay node doesn't know who I am. The only people that it knows about is the entry node because it received information from it, and the exit node because it passed information to it. Now, the exit node can decrypt its envelope. It only knows the relay node. It doesn't know who the entry node is, and it certainly doesn't know who I am. It knows now that I want to go to evil.com, so it sends that off to evil.com, and then guess what? All of that information is then triple encrypted as it comes back to me. Now, you would think maybe law enforcement could use legal process and identify who is this exit node because they went to the web server, so the web server has their IP address, and we could say, hey, where did you get this information from? They'd tell us the relay node. We'd get an encryption key, we'd get legal process for the relay node and then get its IP address of who it got the package from, which is the entry node, and then legal process to get back to the client. But that doesn't happen because every 10 minutes, your your 3 nodes are changed. And as of last month, there are over 7,000 Tor nodes across the world. So it's just impossible to get legal process that fast. And by the way, even if you did, no Tor node is allowed to keep logs. So they don't keep logs for any period of time. Therefore, even if you could get legal process that fast, you wouldn't know the path in which that traffic took to follow it back to the requester, right? Now, as I said, the Tor browser is nothing more than a specially configured version of Firefox. I told you that you can surf the regular internet, the surface and the deep web, with the Tor browser. It's just going to be really, really slow. But you can also surf Tor web servers that are only available on the Tor network and only if you are on the Tor network. So here you can see the top level domain for what we call a hidden services website. That's a Tor hidden services website is .onion. and you can't get to a .onion site using a regular browser. You have to be on the Tor network. Now, if you are surfing the regular internet, remember what I was saying. Here I'm going to google.com, but one of the other challenges to using Tor to surf the regular internet is the web pages that you go to, you have no idea where your exit node is, and sometimes they will be displayed in the language based on where Google or the web server you're surfing to thinks you're coming from. So in this case, you can see my entry node, or what they call a guard node sometimes, is coming from a computer in Germany from an IP that starts with 78.46. Then my relay node is also in Germany, but from a computer starting with an IP address of 144.76. And my exit node, this is where Google thinks I'm coming from, is the Netherlands, coming from an IP address of 51.15. And that's why you see that Google is in French, because it thinks that I'm actually coming from the Netherlands, and the language of the Netherlands is French, right? So here, 10 minutes later, you can see my entry node is still a computer in Germany, 78.46. My relay node is changed to 42.214. Again, another computer in Germany. And now I'm exiting through Moldova. So chances are Google would be displayed in Russian. So again, Tor, the Onion router, is neither evil nor good. It's simply technology. It depends on how you're using it. Technology is neither good nor evil. It's just how we use it that makes it good nor evil. And that's the reason why Tor exists. It can be used for good, such as oppressed countries. Think of people in China, North Korea, and other countries. They can't see the real internet. Their government blocks the real internet and only allows them to see certain websites. Well, with Tor, sometimes they can get past that big brother infrastructure and see what's really going on in the world. So there are legitimate reasons to use Tor, and that's the reason why it continues to exist, and the reason why the largest contributor financially to Tor, keeping it running, is the United States State Department. Right? They're paying over $1 million a year to keep Tor going, and again, it's because these people in oppressed countries, media that wants to communicate encrypted so that no government could see what they're doing, could use the Tor network. So that's Tor in a nutshell. Technology is just awesome.